Okay, so here is the answer key to that video that I promised you, or not the video, the worksheet. Resistant is the opposition to the flow of current, and as the resistant gets higher, the current goes slower. So upon which three factors does the resistance depend? It depends upon the resistivity of the substance, which is just a property of that substance. It depends upon the length of the wire, and it depends upon the area of the wire, which is the cross-sectional area. And if you're wondering what's cross-sectional area, if you had a wire and this is the end of it, this area right here is the cross-sectional area. Okay. Which of the factors from question 1 is being represented in this picture? Well, we've got some obstructions in here. Okay, and those obstructions are things that are opposing the flow of current, and that's just a property of the wire itself. So this would be the resistivity. Which of the three factors from question 1 is being represented in this picture? Well, if you imagine this was a wire, what we've done is we have increased the area, okay, compared with a smaller area. And when we talk about the area, what we're really talking about is either having a pinch point or not having a pinch point. If you have a really, really wide river, obviously it can carry a lot more water than a very, very narrow stream. And so the current, the amount of water, will actually be faster. Even if the movement is slower, you'll still have more water passing a point in a certain amount of time, even if the actual flow is the same speed or slower. So even though the marbles are probably moving at the same speed here, more of them will pass a certain point in a given amount of time. Because if you look, maybe like 1, 2, let's see. Let's do it in red. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons could pass a point in a given amount of time, whereas over here maybe only 1, 2, 3, 4, 5, 6, 7 electrons could pass a point in a given amount of time. Okay, so this one would have a slower current even if it didn't have the obstructions, and this one would have faster current, simply because there's more electrons moving past a point at any one time because the amount of electrons is bigger. When considering the length of the wire, and I didn't put this one as a picture because I didn't like their diagram. He said, you know, as it gets longer, you have more obstructions, but you know, he wasn't comparing, say, one like this, where you have obstructions, to one like this, which is the same area but is shorter. Maybe you only have 3 obstructions. So the more obstructions you have, the slower it's going to go. If you imagine cars going through a parking lot, every time there's a speed bump, they have to slow down. And so the more speed bumps there are, the slower they will go. Okay? And so if you have a longer wire, they simply bump into more things, and every time they bump into things, they get slowed down. Which statement is true? Current is inversely proportional to resistance, or sorry, directly proportional to resistance. And remember, directly proportional means that as current goes up, or sorry, as resistance goes up, so as resistance goes up, the current goes down. Or is current inversely proportional to, oh my God, what is wrong with me? If they're directly proportional, as resistance goes up, the current goes up. If they are inversely proportional, this means as resistance goes up, the current goes down. And the more resistance there is, the less flow you'll have, because that's resistance to the flow of current. So it is the second statement which is true. This one here, this one is false. Okay, so remember this little weird symbol here? Looks like a little fishy. Okay, that means is proportional to. Is proportional to. And current is proportional to resistance. That would be a direct proportionality, as this means as current as resistance increases, the current increases. This one here means as resistance increases. So you can imagine if I had a number 2 down here, that would be like a half. As resistance increases, if I was to double the resistance to 4, now I would have 1 over 4. The current would be 1/4 of what it was. So that really made no sense. I'm sorry, I really haven't had my coffee this morning, so my brain is a little foggy. So if I say things not so smart, that's what's going on. Okay, and this is the one that is true. This is the true statement right here. Okay. Which graph represents the relationship between current and resistance? Well, as resistance increases, the current decreases. And you'll notice it's a curve. This is what it looks like if you have, 1 over 1 is 1 is 1. And then if you increase the resistance 1 over 2, if the resistance is now 2, it'll be a half, and then you'll have 1 over a quarter, and then 1 over an eighth, and then 1 over a 16th, and this is what the shape of the curve looks like if you plot those all out. So this is the one here. This is an inverse relation curve.